Well, hey, it's Dr. J. I'm back with some more marginal averages. My last video dragged on, and I was unable to finish the material, so you can consider this a part three of the section on marginal averages. I'm going to get right into the business applications because I think last time by reviewing some of the rules, I hope it was helpful for you. I hope it, solidified the understanding, but it did, cost us quite a bit of time. So today's lesson is going to be straight to the point, and I'm going to pick up kind of right where I left off last time. So last time we were talking about cost. It was a very interesting cost model, which is not the traditional linear cost model that we developed in other situations. It's a little bit more interesting model. It's logarithmic. And the results, I'm just going to skip all the work. I might do this again, but I'm just going to skip all the work for now. And I'm just going to tell you what we ended with. So we ended with the average cost, which was C hat or C bar of 1,100 units. So X was 1,100 units. Was 75 cents. Yeah, so that's kind of where we left off. And then the marginal average was the derivative of C bar or C hat at 1,100 units, was approximately zero. Yeah, it was such a small decimal that we had to round it to zero. All right. And I just want to talk a little bit about why this is true before I move on. So let me just point a couple things out. It's not actually as if this is costing you nothing. It's that the marginal average is nothing. So if you just look at cost, okay, that's this function here. All right, cost is always going up. Yeah. Now remember, this function was for x greater than or equal to 1, so you can't be charged for nothing. That's not always true. We've seen some examples where even if you produce or you manufacture nothing, produce nothing, you still have a fixed cost. This charges you only when you make the first unit. So we'll call that 1, x equals 1. A quick calculation, if you recall, the ln of 1 is 0. 27 times 0 is 0. So that would be $635. I'm not going to draw this to scale. That would be the cost of 1 unit. And then traditionally, linear cost would go straight up, but this cost kind of goes like this, right? All right. So when you get to 1,100 units, and again, this diagram is not to scale, you still have to pay for those units. All right, I want to make that very clear. There is a price for those units. If you really want to know what it is, I kind of do. Take the ln of 1,100. That's about 7. Yeah, it's going to round, so that's about 7. Which is interesting. The natural log of 1,100 is 7, which means that if you took e, the natural e, and raised it to the 7th power, you would get approximately 1,100. Then you multiply that by 27. Then you add $635. And then you round that. So that's $8.24 and 8 cents. So the cost here would be $824.08 for these 1,100 units. So it's not as if they're actually free. Yeah. So that's why we talk about average cost. Average cost is actually quite interesting to graph. It still starts at 1. It still starts at 635. I'm going to put 635 up a little higher for this graph. So I'm basically taking this piece and exaggerating it. I'm sort of zooming in on this. Yeah, so it starts here. But remember, average cost, this is before I take the derivative. Average cost is just algebra. It's interesting because I never learned it in algebra. I learned it in calculus. So, beginning of this semester, I said, calculus is about 90% algebra, and most of what you learn in a calculus course is, in fact, algebra. But I mean, this could have been, presented to you prior to learning calculus. And average cost is not increasing. It's not going up. It's actually going down like this. Yeah. And so what that means, if you want to interpret these results here, what does the 75 cents mean? Well, it means that when you get way out here at 1,100 units, you are paying for that unit. Right? That unit is not free. Yeah. The average cost for 1,100 units is 75 cents per unit. Yeah. 75 cents per unit. Which is interesting because the very first unit that you produce costs $635. That very first one is the most expensive one. But then the costs sort of level out at some point. And then when you take the average, you divide by X, it turns this thing around, this graph around, which we're going to do a lot of graphing in the next chapter. All right. So if this is like, how did I get that so quickly? I'm sort of giving you a preview into chapter 3. But for today, you just trust me that this is what the graph looks like. If you don't trust me, go and put it on an online calculator or a handheld graphing calculator, and you'll see that I'm right. It might not look as nice as this because I scaled the image so that you could see it nicely. But so what the heck does this mean? 0. What does the 0 mean then, right? Because clearly this is not actually 0. The 0 is the slope. And it's not actually 0. It's approximately 0. So when you calculate the slope at 1,100, it is approximately 0. So that's what we mean when we say marginal average cost. Right? Because I felt like I just kind of got 0 as an answer, and then I looked at the clock and I realized we were out of time, and I just stopped the video, and it was a little bit, it was tough to sit on for the last day or so. So I decided to come back, revisit this. And I want to start today's lecture with an example that's not going to give us 0. So basically, if we come back here and we do less units, right? We produce less units. We'll see, let's say, 200 units. You'll see that the slope is not going to be 0. When you produce less units. Yeah. You'll also have a higher average cost when you produce less units. Okay. And then one more thing I want to mention, why do we care? Why would anybody in business care? I'm not sure how many of you out there are interested in maybe you are business majors. Maybe you're doing it as an academic exercise, or maybe you're actually interested in going into business. I prefer the academic side of it. Like I said, I'm a mathematician. I'm not a businessman. I'm not a business teacher. I dive into the mathematics behind it, and then I let other people deal with the dirty business of buying and selling and making a profit. I enjoy it as an exercise. Now, I don't know what side of the fence you're on, but if you are interested in business, this is very important, the results. Why would you want to do this? Well, it's because you can predict things very nicely. That's the whole idea, right? You don't want to be doing calculus, in the middle of a business problem, right? When you're calculating things. So think about what this does, right? Suppose I didn't have these formulas, right? I've got somebody that works for me, and all I know is that I'm producing 1,100 units, and the average cost, in fact, you don't even need the calculus. You can just do it with the algebra, is 75 cents per unit. This is the type of thing that the boss would want to see, right? They don't want to see all this stuff, yeah. But they do want to know how much it's going to cost, right? Somebody wants to know. Maybe the boss, the board, executive board, whoever is making the decisions, your investors, whatever. Well, watch. Look at how easy it is to reproduce this number. This number is easy to obtain. 1,100 multiplied by 75 cents. You don't have to have any calculus. 1,100, just need a cell phone calculator. And what do you know? $825, which is, again, that's pretty much what that is. It's not exactly, of course, because we rounded and it's an average. But if you were just talking to the boss, right, the boss doesn't need to see this graph. The boss doesn't even need to see the formula, right? That's the beauty of this. You can just talk to them. You can tell them over the phone, or you can text them, or you can give a presentation. 1,100 units at an average cost of 75 cents per unit means it's going to cost us $825 to produce 1,100 units. And then the boss says, all right, go for it. That sounds good to me, right? They see a number that they can understand, and you want to make it simple for people to understand. So I guess that is a motivating factor for all of these calculations. It gets pretty gnarly when we're, doing calculus and taking derivatives and plugging in numbers, and the average person might get lost. But as long as that person, knows how to multiply, and I don't know who that person is, the boss, the board, the public, whoever you're trying to explain it to, as long as they understand multiplying, the bar is very low, then they can understand calculus, or at least the result that you have figured out with calculus. And if you've been doing your homework and getting the answers and wondering why does this matter, well, now I hopefully have motivated you. All right. So that was 13 minutes to sort of explain away the very end of my last video. Let's get started with some more examples. So let's do example 1 again. Let's do the same question again. I know you're going to get sick of this one, but let's produce less units. Find the average cost and the marginal average cost to produce 200 units. So let's just lower the number of units. I'm not going to draw the graphs again. You've already seen it. You know that the average cost is going to go up. It's going to be more than 75 cents. And if I plan this out correctly, which I did this time, the marginal average cost will not be 0. Not that there's anything wrong with 0. If 0 is the answer, then 0 is the answer. But so C hat of 200, 635 plus 27 ln of 200 Remember, this is not calculus yet. This is just arithmetic and algebra, so it does require a little calculus. I mean, a little calculator. So I got 200, got the ln of 200, which is about 5.29 or 5.3-ish. Doesn't really matter because I'm going to multiply it by 27. I'm not going to round it yet. Don't round until the very end. Then I'm going to add 635. And then finally, I'm going to divide by 200. You can do the whole thing on your calculator. I do it step by step. I have seen students type the whole darn thing in and get it right. But I've also gotten it wrong that way too. So this one's nice to round. It's $3.89. Significantly more, yeah? Again, you know, because you're producing less units, the average cost for each unit is going to be more. All right. So this is dollars per unit. All right, now let's do the average marginal. First, we have to do it with X. Can't plug in the 200 for this one yet. So you're going to take the derivative of this. Oops, I forgot. I'm going to take the derivative of 635 plus 27 ln of x over x. All right, so that's the derivative of the top, which is 27 over x. Yeah, derivative of 635 is 0. Ignore the 27. Pull it out to the front. Derivative of ln is 1 over x. I think last time I wrote 27 times 1 over x. It means the same thing. So derivative of the top times the denominator, times the bottom, minus the derivative of the bottom, 1, times the top, 635 plus 27 ln of x, all over the denominator squared. So that's 27, these x's cancel, minus 635 minus 27 ln of x, all over x squared, which we calculated to be negative 608 minus 27 ln of x over x squared. Does that match what we had last time? It should. Just double checking. 27 minus 635. Yep, negative 608 minus 27 ln of x. All right, so now we can plug in the 200 units. C bar hat 200 units. Negative 608 minus 27 ln of 200 units over 200 squared. And again, you can just do this on the calculator. 200 squared is 4 with 4 zeros, so 40,000. I'm just saving myself one step later on in the process. All right, so start with the ln. So you got 200, ln of 200. We already knew that from earlier. Times 27. Technically, that's negative 27, so I'm going to put the negative in now. And then I'm going to subtract 608. So that's the entire numerator. And then I'm going to divide that by 40,000. And I'm going to get negative 0.0187, which is going to round the 8. You can ignore the 7. That doesn't matter. It's the 8 that decides. It's the dictator. It's going to round that 1 up to a 2. So that's going to be 2 cents. So that would be our marginal average cost. So now we can look at the two things. Marginal average cost is decreasing, at a rate of 2 cents per unit. And again, calculus is the study of change. So when you talk to your, colleagues, people you work with, your boss, whoever is interested in this kind of information, you're basically saying, well, when we produce 200 units, it's $3.89 a unit, right? And then again, on the side, you can say, well, by the way, that means that if you produce all 200 units, you just multiply these two. I'm not asking that question in this assignment, but on a side note, you could say $3.89 times 200. So it's going to be $778 to produce these 200 units. However, costs are decreasing by 2 cents per unit. That means that each unit costs 2 cents less than the previous unit. It's getting cheaper and cheaper and cheaper and cheaper to make these things as you increase production. And as we saw at the end of the last video, and now again, deja vu, the beginning of this video, if you make enough, you get out, into the thousands of units, this marginal average goes to zero, which essentially means you might as well keep on making them, because it's not actually free. It's just approximately zero. The old saying goes, nothing in this world is free. But when you round it, with rounding, you can say that it's approximately zero. Okay. So that was revisiting cost. Kind of break the ice on this video, get right into business. If there are no questions, do I hear any questions? If you have questions, email me at Dr. Jordan, College of the Desert. Okay. That's not actually my email, but if you're in my class, you know my email address. Okay. Well, we don't just want to spend money in business. You got to spend money to make money, right? So now we're going to make money. So let's talk about revenue. So I was watching the Oscars the other night. Actually, I think it was last night, but I don't know when you're going to watch this video. This video was filmed in the spring of 2024. And I was watching the high-end fashion brands and people on the red carpet, and it inspired me for this next problem. So the revenue from selling high-end, notice in the last example, I didn't even know what we were selling. It didn't matter. I was just calling them widgets or gizmos or something. So these are high-end fashion shoes. You're wearing fancy shoes on the red carpet. Is given by $220x plus 0.0007 e to the x. All right. If you really like to see what's going on here, this is a very, very steep curve. If you sell no shoes, you make no revenue. So it starts at the origin. Although it's just a tiny bit above the origin, right? Because you do have this 0.00007. So if you plug in 0 for x, you'll get 0, right? 220 times 0, plus this will be 1, right? E to the 0 is 1. So, but this is less than a penny. Yeah. So I guess technically it's 0.0007 if you sell no things, which is approximately 0. So I'm just going to say 0, 0, right? And then what happens is the revenue just goes like this. Shoo, like that. Right? Because these are high-end, very expensive shoes, right? And you don't have to sell very many pairs. to make a lot of money. So let's sell 19 pairs of shoes. So find the average revenue and the marginal average revenue by selling 19 pairs of shoes. All right. A pair of shoes is called a unit. It's interesting. It takes 2 pairs of shoes to make 1 unit. Obviously, nobody's going to buy just 1 shoe. I think everybody already knows that. They come in a box. They're in the same box together. And the box that the 2 shoes come in is a unit. I don't have to tell you that. You already knew that. So R hat of 19. How much money are we going to make selling 19 pairs of shoes? On average. So there's your average revenue from 19 pairs of shoes. You might want to do a little prep work. Do the 220 times the 19 first. And then you could do the rest of it nicely. So we got, start with the E. So E to the 19. It's your E to the X. That's very large. Yeah. Now you don't get to keep all that money. You got to multiply it by 0.0007. Oh, I messed up somewhere. Let's try that again. 19 E. It's a huge amount of money times 0.0007. Oh, it's still a ton of money. Look at how much money we made. $124,937.61. And again, it's 610674. Don't round yet. Divided by 19. Go ahead and add these together. Plus 4180. A little extra. Yeah. And then divide that by 19. And let's round that to 2 decimal places. So this is dollars per unit. Not bad, yeah. That's why they're high-end fashion shoes. You only have to sell 19 pairs of shoes, and the average would be $6,795.66 per pair of shoes or per unit. Now, what's crazy about this problem is that's sort of the, how much money you're making here, on average. But now we want to know how fast the revenue is going up. So that's the one where you take the derivative, right? And you can kind of tell what's going on here. You can kind of see what's going on. The revenue is increasing very rapidly. So let's do R hat prime. Or R bar prime. I still like to call it a hat. 220x plus 0.0007 e to the x over x. First, we have to take the derivative. So we'll take the derivative. Oh, shit. Take the derivative of this. I have not yet taken it yet, so I'm putting this ddx on the side just to remind me that I haven't done it yet. All right. Now I'm going to do it in this next step, which means I can remove the ddx in the next step. So derivative of the top. Now this is a little more complicated now. So derivative of 220x is 220. Remember, the derivative of e is just e, so that's just going to stay the same. The constant comes out, and then the derivative is e. So that's the derivative of the top times the bottom minus the derivative of the bottom, 1 times the top. Let's see if I can squeeze this in here. All over the denominator square. Let me just save this. 6795.66. That's my average. All right. So what do we got? I could plug in the X now if I wanted, but I'm just going to try to make it a little easier on myself. So that's going to be 220x plus 0.0007x EX. Normally when I multiply an x times an exponential, I squeeze it in the middle here. You don't have to do that. You could put it out in front or at the end as well. That's just a tradition that I've learned in my life, and I just follow that tradition. Now I'm going to distribute this -1, so that's going to be negative 220x, and then negative 0.0007EX. And I'm glad I did that now, because these 220s will cancel. And so my R prime hat, forgot my hat, is 0.0007XEX minus 0.0007EX all over x squared. I'll leave it to you if you want to simplify more. You might want to. It might help you. Maybe I won't leave it to you. I'll just tell you what to do. Pull out the EX, and then you only have to do it once. Yeah. So now let's plug in our X. What was it? 19? So that's going to be 0.0007 e to the 19 times 18 over 19 squared. Yeah, you see how x minus 1 becomes 18? Because you're plugging in 19. And I think we could do this whole thing on the calculator. I'm going to do the 19 squared first. I don't remember that from being a kid. 361. Nobody ever makes you go all the way to 19. 12 is pretty standard. I went to 15 when I was a kid because I was not normal. So 19 squared is 361. We got to do the rest of this now. Do the E first. So you got e to the 19. That's huge. Remember, we saw that earlier. I mean, if you already wrote that down, then you already have it. It's like $178 million. Times 0.0007. It's still a lot of money. It's, $124,000 times 18. So you have this big number, 2,248,876.99. Don't forget, you have to divide it by 19 squared. So divide that by 361. And you get approximately, it's a very similar number. 58 cents. I'm rounding 0.576. I'm rounding to 0.58. All right. So those are your two answers for revenue. I guess it's a good business to be in. Now, one thing Revenue doesn't really tell you how much money you actually made. It's just how much you brought in by selling these things. You have to include cost. I don't know. This example doesn't tell me what these shoes cost. Maybe these shoes cost $5,000 a pair to make, or maybe they don't, right? Maybe you make them for $10 a pair and you're just fooling everybody and running away with the money. I don't know. That's for the manufacturer to decide. So just to summarize the answers, we ended up with an average cost for 19 pairs of shoes. The average cost was $6,795.66 per unit. And then the average marginal cost, or the marginal average cost, I say it both ways, $6,229.58 or dollars per unit. So what does that mean? That means when you get to the 19th pair of shoes, the revenue is increasing by this much per unit. So sell another pair. Okay. It's a coincidence that these are both in the 6,000s. It's just the way the numbers rolled out. Generally speaking, for this type of high end, we use the E. It's exponential. It just goes up crazy. It's not a straight line. You'll see that these numbers will be very large numbers. I don't know exactly what they're going to be. It really depends on the values that are in your particular example. But I just wanted to kind of show you one example that I came up with. Okay. Now we're going to make some profit. Now to make profit, you have to combine the revenue and the cost. I was not inspired to make a product here, so we'll just call it a product. So a company uses the functions C of X is 45 square root of X plus 790, and R of X this is a more standard type of revenue model, or an everyday product, I guess. It's not high end. It still increases pretty quickly, but not nearly as much as the shoes we just talked about. The cost model is very similar to example 1. It's not the same. It's not a logarithm, but it does have a very similar curve to it. It's not a straight line, which means these are interesting because I just want to say something before I do the problem. I hope that you are, learning by my commentary here. If there was no square root, then this problem would be much simpler, right? Because it's a line. It would also mean that every unit X, I don't know what this is, I'll just say these are units, would be the same price, $45. Yeah, the same cost, not price, cost. I got to be careful with my language. This is the cost. So $45 for every unit. But when you have the square root, or when you have the logarithm, or when you have some other function involved, it curves the graph typically and changes the cost as you go along. It makes the problem more interesting. Yeah. Same thing with an exponent. Yeah, this is not a straight line. This is a curve. It's not quite as steep as the one we saw in the last example, but it is pretty cool. So where X is the number of units produced and sold. Okay. Sometimes we say respectively. Okay, let's sell a lot of units here. Let's find the average profit and marginal average profit when 1,200 units are produced and sold. I could have just said X equals 1,200. It's a much easier way to say it. All of that just means X is equal to 1,200. All right, well, let's get into it. We got a lot of steps to do here. Profit's a little more complicated. Remember, profit depends on the number of units that you sell. It's equal to the revenue minus the cost, and I always put parentheses around the cost. All right. And then you distribute the negative. If you want to save yourself some writing, you could just do that as you're writing it down, as long as you don't forget that you've already done it. I know I've done that and forgot that I did it and then go back and do it again. So that's my profit function. All right, so now I want average profit. Just copy this down and divide by X. Unfortunately, wait a minute. I boxed it too soon. When I divide by X, yeah, let's do that. I thought I could simplify it a little easier, but let me just show you. A nice technique for dividing by X. I didn't do this in the past because I was trying to teach the concept. And sometimes when I teach the concept, I just stay very traditional. I don't like to employ any fancy tricks, but you've seen a lot of these now, and I want you to be able to sort of streamline and be a little more efficient with your calculation. And so when you divide, I was about to write a big bar with just one X, and then I went, wait a minute. I can just write 4 individual X's and watch what happens. Your average function becomes very, very easy to calculate. The only trade-off with this is now you've got these square roots in the denominator. This one's a little tricky here. So this is X to the 1/2 over X, which is X to the 1/2 minus 1, which is X to the negative 1/2, which puts the square root down in the denominator. The 45 is like right here. The 45 is a constant that's just kind of riding along on the side of the X. And so when you're done, the 45 just stays in the numerator. All right. Now, again, that's optional. You don't have to do that if you don't want to. You could just write a bar with one X and do it the same way we did all the other ones. But I'm giving you options as we move along in this course. You get more sophisticated. You get more freedom. you got more ways to get to where you want to go. What were we asking? 1,200 units? All right, so I got 0.13 times 1,200 plus 450 minus 45 over the square root of 1,200 minus 790 over 1,200. All right, so calculator fun here. I don't know what to do first. Let's do this first. 1200 square root. We're just going to write that down, 34.64101. I'm going to kind of do this piecemeal here. Let's do 790 divided by 1200. That's when you're doing these piecemeal, you just do each one individually, term by term. It's going to be ugly, but it'll work. And then I got a 0.13 negative, so negative 1300ths times 1200. Negative 156. That came out nice. And now I'm just going to kind of go across here. Let's start here. 45 divided by, start with the more complicated one. 34.64101. All right. Oh, that's negative. So be careful. That's negative. The negative goes with the 45. Let's do this next. Just get rid of these ugly decimals. Minus 0.65833333333. All right, so that's just these last two terms. Then I'm going to add 450. And then I'm going to subtract 156. As long as you pay attention to the signs, it doesn't matter what order you piece them together. So I get 292.04. And again, that's dollars per unit. Not bad, whatever this is. It's not high-end fashion shoes at the Oscars, but you know, maybe it's a television, or I don't know. I don't know what they make on televisions, but maybe even less than that. I don't know. I've never sold televisions before, but so whatever it is, they're making on average. Again, on average, if they sell 1,200 of these, gadgets. They're going to make $292.04 for every unit. So that's the average analysis. And now let's do the marginal analysis. How much, what are the margins, the little slopes? Yeah, is it going up? Am I making more money? Which is an important thing to know. It's like predicting the future, right? If the slope is going up, then you're doing good. If the slope is going down, then you maybe need to adjust your model or adjust your prices or whatever it is. So let's see. Let's do the profit, the marginal analysis. Let's analyze the margins. So now that I have this written this way, one advantage to writing it this way is the derivative is going to be very easy. Maybe I will do this to make it even easier. 45x to the negative 1/2. Yeah, I remember from earlier in the chapter, square roots are the same as halves. And then I'm going to write this 790x to the negative 1. When you're preparing to take a derivative, getting rid of square roots and writing them as half powers makes it a lot easier because you have the rules that we learned. And similarly, dividing by x, we could use the quotient rule, which I taught you the quotient rule, but if you write it as a negative 1 power, then you can avoid the quotient rule as well, and you can just do it as a power. Okay. I want you to know both methods, right? And I want you to be able to choose the method that works best for you. So, okay, so this is now the marginal average. So let's take the derivative. Watch how easy this will be, right? Going all the way back to the beginning of the chapter on derivative rules, you can just go term by term by term by term. Put your ducks in a row. So the derivative of the first term is just negative 0.13. The derivative of the second term is 0. right? I'm not going to really write that. I just wrote it for you. That 0 is going to get erased in a minute. The derivative of the second term is a negative times a negative. So that's going to be a positive 45 halves. Now, if this was an even number, I would actually divide it by 2, but it's not. I'm just going to write it as 45 halves. I'm going to put it in my calculator. It's going to give me a decimal. That's going to be x to the negative 3 halves. So I'm subtracting 1. Subtract 1 from negative a half, so I get negative 3 halves. It's also negative 1.5 if you prefer decimals. And then another plus, because it's going to be negative times a negative, plus 790 x to the negative 2. Remember, you're subtracting 1 from the powers. So that is your marginal average. So now we're going to plug in, what was it, 1200. And there's only these two x's to plug into. I'm going to be very careful here. This is going to be 45. Actually, let's divide this out. I don't like 45 halves. It's going to be 22.5 over, right, the square root of 1200 cubed. All right. I could cube it on the inside or the outside. It looked a little messy on the inside, so I put it on the outside. And then this one's going to be 790 over 1200 squared. So you can write negative powers when you're performing the simplification and the derivation, taking the derivative, using the rules. But when you actually go to plug them into your calculator, you don't want negative powers, although some calculators allow it. I'm using my phone calculator because it shows nicely on the screen here. And I want to make sure it looks like what I think that it is when I'm calculating it, right? Right. So when I see negative 3 halves, I want you to know that you're actually taking a square root and cubing it. That's what you're actually doing. And then when you see negative 2, I want you to know that what you're actually doing is squaring and dividing. So I'm really a big fan of, not just getting the right answer, but understanding where that answer came from. If there's anything you get out of, spending 15, 16 weeks with me watching these videos, it's a better understanding of what things mean. Those might be things that carry with you into your career and your future education. That's really my job. Much more important than just giving you a grade and telling you got the right answer. All right, so I got negative 0.13 plus 22.5. I'm going to do this 1200 square root business here. 1200. Square root it first. Gives you 34 point something something. And then cube it. Oh, there's a cube button. So that's 41,569.21938, blah, 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 blah. If you're going to keep it on your calculator, I like to write it down in case I screw it up, because I often clear out my calculator like that. 790 over 1200 squared. Now that's not square rooted. That's just straight up squared. That's 1,440,000. Yeah, it's like 12 times 12, 144. It's 1,440,000. All right. Again, I'm not going to add these until I'm done. So let's see. We got 22.5 divided by 41,569.21938. You don't really need all those decimals. I keep a few of them just in case they end up affecting the final answer. You never know. The smallest thing can cause a large change at the end. So it's better to keep everything. All right, so I did 790 divided by 1,440,000. I get this tiny little decimal. At this point, I'm just keeping it on my screen. Keeping it on my screen, and then I'm going to add them all up. Keep track of the signs. So then plus 0.0005. Interesting how close these are to each other. 5, 4, 1, 2, 6. They're not identical, but they're close. And then minus 0.13. That's like the dominator there. That's 13 cents. So you're going to get negative 12.89, which is really just back to 13 cents. Notice that this is very close to zero. This is very close to zero. So had I noticed that sooner in the problem, I could have said, well, that's going to zero. That's going to zero. So the 13 cents is going to dominate. If you notice that when you're doing the problem, maybe you can save yourself some of this calculation. However, I will warn you, I've done this problem 100 times, not today, but, in my life. And sometimes these things are very small, but when you add them, it gives you another penny. Yeah. And if it's another penny, that's why I kept all these decimals, then it would change this 13 cents to possibly 14 cents. Or possibly the other way, 12 cents. I don't know. It's negative, so I guess it would be 12 cents. Negative 12 cents. Okay, and it's kind of cool. Yeah, I have both my answers here. So I have my P hat bar, or P prime hat, and then I just have my P hat, my profit. So I want to just kind of talk about the two answers since they have them right here. This is dollars per unit, and it is decreasing. Yeah. For the average, you don't say increasing or decreasing. You just say it's a profit. Average profit, AVE. So it's not increasing or decreasing. It's just that's good. Yeah. Anything that's positive is good. If profit comes out negative, it's not really a profit. It's a loss. It means you've lost money. So the profit is positive is good. Yeah. Unfortunately, the profit is decreasing, which is kind of like I don't know. That's not good. So I'm still making money, right? We're still in the black, they say, yeah. But we're losing money every time we sell another unit. Now, we're not losing much. We're losing 13 cents on average, right? So, it might be time to rethink our model, rethink our scheme that we have going on here, right? You never want your marginal average to be negative because that means it's going the other way around, unless it's cost. Cost, if this was cost, that would be a good thing. I forgot to put happy and sad faces on the cost. When the cost is going down, that's good, right? Because it's getting cheaper and cheaper, as you know. But if the profit is going down, that's not good. All right. Unless you're trying to lose money. I don't know. Most people don't get into business trying to lose money, but there is. I've watched American Greed. My kids still make fun of me because I watch cable television. I still pay for it every month. I don't know why. I know. I got streaming, but I still watch regular television, and there's this show American Greed, um, and some folks get into business with full intention of losing money um, out of their own greed, because it turns out that you can profit from other people's losses, and they always get caught. Yeah, they always get caught. So let that be a lesson to us all. One of the reasons why I'm a math teacher and not a businessman is I don't like to get my hands dirty unless it's whiteboard ink. Well, that brings me to a little story. So example 4. And this is quite a story. This is the quintessential business math word problem, okay? When you're preparing for your chapter exam, I want you to know all the techniques, of course, yeah, all the rules, all the algebra, manipulating variables and such, but there's typically at least one of these, probably not more than one of this type. This is pretty intense story type problem where I don't give you anything but a bunch of words. All right. It's the real sort of combination of math and critical thinking and reading and writing and everything. So it all comes together in a story. Now I call it a story, but it's just a bunch of words. I'm not really going to sit you down and read the story to you. So suppose a handmade object, I'll call it an item, is produced and sold at a outdoor market. So, a street fair, or, the village fest or something, a swap meet, what we used to call them swap meets back in the day. To rent the space, costs $1,800 per month. Is it per month? Per week, sorry. You only get it for a week. And back in the day, that's really just Saturday and Sunday, right? Because the swap meet would only be open on Saturday and Sunday. Or perhaps, maybe it's only on Thursday night or something. But whatever it is, it's $1,800 per week. However many days the outdoor market's open. I'm not going to get into that. It could only be open one day a week. But maybe you're lucky it's open 7 days a week. Each unit, remember, a unit and an item are the same thing, costs $6 to make. So it cost me $6 to make each one of these items. When the price is $161 per unit, only 55 items or units are sold each week. Now, this is a handmade item. Maybe it's, a very fancy hat, or a very, maybe it's artwork, whatever it is. It's whatever you want it to be. You imagine whatever you want it to be. But it's handmade. It's expensive, $161. Yeah, for one. But only 55 of them are being sold in a week. I guess only. Maybe you're happy with that, right? However, as a business person, you want to experiment with the pricing. I always mention this to folks when I'm, I'm shopping. I don't do this at a grocery store or anything, but if you're at, you're at a market, flea market, something like that, even a farmer's market. I love the farmer's market types of problems. I ask them these questions. I teach business calculus. I wonder, do you play around with your pricing? And most of them say yes. I haven't met anybody yet that says that they actually do calculus, though. They just use gut instinct. They just use their, I felt like lowering the price. So, twice as many items or units or items, I go back and forth, are sold when the price is reduced. So this is what the folks tell me when I talk to them at the street fair or something. They say, yeah, I just kind of do it, and I just see what happens. So they'll lower it to say $128. I just made these numbers up, but it works out nicely in the story. And they just kind of do it with their gut. They don't actually do the math. And I tell them, well, I'm interested in how you're doing it. And sometimes I listen to their stories. And so this is actually taken from a real life experience. I kind of fudge the numbers a little bit to make it a little bit easier on the calculation. Turns out if you use real life numbers, it's pretty ugly, which might be something we dive into later, just sort of embracing the difficulty of the real world. But I've sort of idealized the numbers, but it is, extracted from a real life story. Okay. So what are we interested, right? What do we want to know? That's the story. Yeah. This is all the information that you're going to be given. So here are some questions that I'm going to ask. How many units must be produced and sold each week to guarantee the average marginal average, it really doesn't matter, but I want to say it right. Marginal average profit is $2.43 per item. In other words, as a small business person, as an entrepreneur, you don't want what was happening in the last problem to happen. Right? In the last problem, the margins were going down. Yeah, I was losing money every time I sold something, which that's a red flag that something's going wrong here. Okay, so I want to just sort of, before I even get going, I want to decide what's my production. How many of these am I going to make and sell each week, right? Now, of course, you can't guarantee that you're going to sell them all, but you can certainly have a target, a goal, right? And I want to be making an additional $2.43 on every item that gets sold. So I'm setting a goal. It's sort of a production sales goal for my model. All right. I'm also going to ask a couple other questions. This is the big question. Once we know the number, so we need this first. Then I'm going to ask, what's the average profit? It's not going to be $2.43 because this is the marginal profit. It's just the little tiny margin for each unit. I want to know the average profit overall, yeah, per unit, and then I want to know the total profit. That's the big one. That's sometimes what we call the bottom line. I can't answer these two questions until I first have this answer. All right, so let's get into this. We got a lot to do in a very short time to do it. All right. Now, fortunately, I've given you everything you need. All right. The cost is the variable times variable cost times X plus the fixed cost. Variable, each unit costs $6 to make. And fixed, that's the rent. Yeah, fixed cost is like rent, also known as overload or overhead, not overload. So my first model is very easy. 6x plus 1800, done. All right, we got that done. Go ahead and erase that. Now a little bit harder. Little bit harder. I've got my price number one. Call that P1. Be very careful. This is not profit. You could actually use Y1 if you prefer. It's probably not a bad idea. And then this is your X. So that's your X1. In other words, if the price is $161, then this is how many units get sold. Now, so twice that many. So my P2 or Y2 is going to be twice that many. Oh, sorry. Twice that many is X, not Y. Sorry. X2. Twice that many, so that's going to be 110. Here's my P2 or Y2, whatever you want to call it. So I have P1 is 161, X1 is 55, P2 is 128, X2 is 110. This is called price demand. You've seen this before. So price is a function of X. So first find M. It's going to be 128 minus 161 over 110 minus 55. Right? P2 minus P1 over X2 minus X1. Which is why I said you could use Y's. From basic algebra, right? Your P's are just like your Y's. So if it makes it easier for you, then just call it Y equals MX plus B. That's the same thing. Okay. All right, let's do our slope here. So I know the bottom's just going to be 55 because that's just subtracting, 110 minus 55 is obviously going to be twice that. So 110 is twice 55, so it goes right back to being 55. The numerator, I want to make sure I don't screw up. So that's negative 33 divided by 55 is negative 0.6. So that's my M. Negative 0.6. I just wrote down my goal here. My acronym is MAP, Marginal Average Profit, just so I don't forget what my goal is. Okay, so now I've got y equals negative 0.6 x plus b. There are more sophisticated methods for finding this equation from basic algebra or intermediate algebra. I just always go back to this because it's so much easier for me and for my students. I just pick one of these pairs. So price is 161. Just pick one. And then pick the corresponding x. Let's do 55. Make sure if you pick one, you pick the one that goes with it. So 161 and 55. Or you could have picked the other one. It doesn't matter. Either one of those given numbers will tell you what the B is. The B is a prohibitive price. It means that if you charge that, nobody's going to buy it. I multiplied these on my calculator, got negative 33. I add it to both sides, $194. Okay, so price demand is negative 0.6 x plus 194. All right, take a look at that. Make sure you're all caught up with where we're at. I'll talk for a second while you're getting caught up. You can always press pause if you need to. So essentially what this means is that $194 is too expensive. That's why we do the price demand. That's again the conversations that I sometimes have with small business owners. If you know how to do this, it's very useful. It kind of gives you a ceiling. It says you should not be charging $194. And sometimes I'll find just through conversations with people that people are charging too much. And they're wondering why nobody is buying their product. And ultimately, in a couple months, I don't see them at the street fair anymore because, nobody bought their product and they couldn't afford the rent, right? Because those spots are expensive, depending on which market we're talking about. But so that is prohibitively expensive. Nobody's going to buy it for $194. If you read the story again, I was pretty close to that at the beginning, right? But I wasn't quite there. It was $161. So still below the ceiling, yeah. And then the negative 0.6 is the price margin, right? Again, I haven't even taken a derivative yet, but remember, with a linear function, the derivative is just the slope. Right? You see how everything's kind of coming around full circle? So the slope is negative 0.6. If I did take a derivative, it would just be negative 0.6, which is 60 cents. So essentially, it's dropping 60 cents for every additional unit that I sell. Yeah. So if I sell more, I can drop the price. Or vice versa. If I drop the price, I will sell more, which is really the optimistic way of thinking about it. Okay, so we're ready to do some calculus now. So that whole beginning is just taking the story and turning it into your two models. All right, now remember, you want profit, so you need revenue. Revenue is very easy. You just multiply this by X. I don't even show the math anymore. I know I did once. And then now you have profit. Profit is revenue minus cost. And remember, I said put parentheses around the cost or just distribute the negative as you write it down. So as I wrote it down, I distributed the negative and changed those signs. So this gives me my profit function. All right, there's my profit function. Now, here's our goal. Our goal was marginal average profit of $2.43. That's our goal. This is just profit. So now I need average profit. I'm going to do that trick again, or technique, dividing them individually instead of all at once. If you prefer doing it all at once, you certainly can. It's not wrong. But I like this technique because look at how nice everything comes out. The only trade-off is you end up with this fraction in the end. You can't ever get rid of that one. But it does make the first two terms very nice. I'm going to save this because we might need it later. I think we will need it because I asked what was the marginal profit. I mean, what was the average profit? So now that we have the average profit, let's do the derivative. So that's going to be the derivative of negative 0.6x plus 188 minus 1800. And I'm writing this as x to the negative 1 power. Yeah, that's this denominator here. I'm writing it as, there's an invisible 1, and I'm putting it up and writing it as negative 1 so that I can take the derivative. All right, and again, this is just reminding me that I have not yet taken the derivative. I'm about to. All right, so here's my marginal average. Derivative should be very simple. Just march down term by term and take the derivative. The derivative of negative 0.6x is just the slope, negative 0.6. See how nice that is? Now the middle one's going to be 0. And then the last one's going to change to plus because you have negative times a negative. 1800 x to the negative 2. Or I'm just going to write it. No, I'm going to write it as x to the negative 2. Go ahead and get rid of the 0 and write this as 1800 over x squared. So this is sometimes called the MAP, marginal average profit. My goal was to set this equal to $2.43. Now, I'm right-handed, so I like to solve this way to the right. So I'm just going to move this sucker over here. But it really does represent this, right? It represents the MAP, the marginal average profit. It is essentially the output. I like to put the output on the right-hand side. Okay. Just makes it easier to solve. So then I'm going to add 0.6, which is 60 cents. That's going to be $3.03. All right, I'm going to multiply both sides by x squared. I'm going to divide by $3.03. I need my calculator. 1800 divided by $3.03. So I'm going to get x squared equals 594.059, blah, 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 blah. Doesn't really matter. I'm about to take the square root of both sides. So I'm just going to leave it on my calculator, take the square root. Now, because these are units, you can't have decimals, right? So we're just going to say 24 units. I'm rounding. So I'm rounding to the nearest whole number because it's not money. Money, you can have pennies, right? You can have dimes and nickels and pennies and things. You can't have 0.37. You could argue that even if it was 0.5, that you shouldn't round up because 0.5 is not really a whole unit. But I'm just going to have you do traditional rounding rules, which is if it's more than a half or equal to a half or greater, then round up to 25. This is less than a half, 0.37. So round down to 24. That's a whole nother discussion about whether or not half a unit should be rounded up to a whole unit. One could argue no. Half a unit is still no unit at all, and so you always round down. That's a different philosophy. I'm just using standard math, techniques. So that's it, 24 units. So in other words, I need to slow down, right? If you read the story at the beginning, sometimes it's better. Less is more. Yeah. That's that whole philosophy. Less is more. My profit will be increasing at a greater rate if I make and sell less. Now, I have to learn to live with less, right? But maybe that's good. Yeah. I could diversify. Maybe have some other products that are cheaper. So that when people come in, you're cheaper, that are easier to make, that'll get them into the door. And then you only have to sell 24 of your big ticket items. So X is 24 units per week. P bar hat of 24 will be $2.46. Yeah. What is the average profit of 24? That's why I saved this. Yeah. So this will be negative 0.6 times 24. No calculus here, just algebra. 1,800 over 24. Just keep this, and you might need it later in the problem. Let's see, 0.6 times 24 units. So negative $14.40 plus $188 minus 1,800 divided by 24. 75, and now it's just arithmetic. So that's negative 75 plus 188 minus 14.4, $98.60 per unit. Not too bad. By making less units, my average profit has gone up. Yeah, I'm making more money. You go back to the original story with all of those units that they made, and they sold, 55 units, the average went down. So now we have an increasing map, marginal average profit. Yeah, it's going up. That's good. Yeah. I'm making $98.60 per unit. Profit, by the way. That's my money if I'm the entrepreneur. Much better than revenue. And sometimes you get a very large revenue and you get excited, but you can't keep all that revenue. It's the profit you get to keep. That's your paycheck. And then the total profit, total weekly profit. Watch how easy this is. You take the average, 98.6, and you multiply it by the number 24 units. The whole point of doing this is to stay in business and to have an easy calculation. And this is dollars per week. Or you can just say dollars. I mean, I guess I already said weekly, so I don't want to be redundant. Not too shabby. That's profit. That's after you've already paid the rent. Yeah, you've already paid the $1,800 in rent. You've already manufactured all of the items and paid for them to be made. Right? You're selling them at $98 a unit and you're making $2,300 a week. Not too shabby. You get to stay in business and you get to live another week. Well, this was an event, right? This is the end of marginal analysis. It's certainly not the end of business math, but it's certainly the end until we learn some new techniques. So stay tuned for more. But until we meet again, I'm Dr. Jordan, and I'll see you on the internet.